Hello all, welcome to your channel DIY Community. Please subscribe to this channel and get access to exclusive content and resources. You will also become part of our DIY community where you can connect with like-minded individuals and receive support. Hi there, welcome to your channel DIY Community. So in the previous video, we have seen how can we design and develop a message bus server using core Windows and Linux APIs. I'm pretty sure you might have noticed the overhead you have to write to make it portable to run on Windows and Linux. So some places the code was duplicate. So these are only for two operating system. Imagine you have to write a similar thing for a different machine. One way you can solve it by using an intermediate portable library. And if you are a professional C++ programmer, then I'm pretty sure you are aware of Boost. So if you are not familiar with Boost, then I will recommend you to go to this first video. So here we have discussed on how to download and how to set up Boost for your machine. Now this is not that complicated. There are all like pre-built binaries. You can simply download them and use them. It's as simple as that. Now one more reason why I will recommend you to learn Boost is Boost is a playground for all C++ features. Whatever the features which you are using in C++, basically they are first introduced in Boost, and that's where it gets stable, and then they are moved to C++ core libraries. So in this video we will see how can we design the same thing more professionally using Boost. So if you are behind on this educational video, then I will also advise you to go and catch up with the remaining stuff which we have discussed before. The reason is whatever you're learning here, these are like baby steps. For example, in this particular case, a message bus. So we are going to use all these components to design our much larger systems. For example, if you see, this message bus is a component which is like a core component of this trading system here, and we will also design trading exchanges and other order management systems we will see. So all these various components we are going to look one by one, but the basic stuff is this message bus here, which will lay a foundation for whatever we will do in the future. And if you have not subscribed to this channel, then I will request you, please kindly subscribe to this channel, and because it will motivate us to bring more useful content for you guys. Now, based on your requirement, you can implement a message bus in various ways. For example, in this case, you can have a system where you have to broadcast some updates to all the clients in an order management system. For example, if a trader is booking a trade, obviously when he is performing or she is performing some operation, you want that to be visible on all other client systems. So you can have a message bus in the middle, and message bus can broadcast that information to all the client asynchronously. Similarly, if you want to have a system where if some update is happening, you want to redirect that to a particular server or a system, that can be implemented with a message bus too. Or a third flavor is if you want to broadcast your message to certain people in your group, that can be done with message bus too. Similarly, you can have other types. For example, here these people are, or these systems are doing point-to-point communication. So it all depends upon what exactly you need. You can customize your message bus in that way. So let's see a basic implementation of a message bus, which is something like this, but based on your requirement, wherever you're working on, whichever project you're working, you can very easily customize it to anything which is shown here. Now, similar to our previous application, where we have used Windows and Linux socket APIs, we will use exactly similar model here. So we are going to design our message bus. It's broker, but we will design a message bus, and it will have a proxy and service. So every time a service tries to connect to our message bus, the proxy will get registered into the message bus. And whenever this service sends a message, broker will have the list of all the proxies, and it will broadcast the message to all the services. So this is exactly what we are going to do here. Now, as we have done in our previous Boost applications, we are so this is our proxy class. So this is so here we are declaring all our headers and all namespaces, whatever is required. Now we are going to share this proxy. That's why I have enabled this template enable shared from this. And there is a constructor which is maintaining, or which is taking this socket parameter, and it is assigning this socket parameter to the socket object here. And we are also maintaining a variable, boolean variable to maintain if this socket is still connected or not, and then it will also contain a data in it. We are going to use a very simple data structure here with some form of like header and detail. That's it. But we will see more complicated implementation and more flexible implementation in our next videos. Now, just to keep this thing simple and focus only on the implementation of our message bus, we are not introducing any complexity here. So it will have a start function which will trigger as soon as this proxy starts, and there is an update. We'll see all these things later. Similarly, we will have a message queue manager. Message queue manager, so we are declaring all headers which are required here, namespaces, declaring a forward declaration of proxy, and we are maintaining a singleton instance of this message queue manager. So basically this message queue manager is a core of our implementation. It will maintain a list of proxies and list of messages, and as soon as it gets a message, it will broadcast that message to all the proxies. So this is a static instance of message queue manager. We will have a start function and interfaces to add and remove clients, and similarly there is an interface to add message and interface to add a broadcast message. And because it's singleton, so we are making this constructor private. There are a lot of other things which I'm supposed to do, but as I said, I'm not focusing here on class design, but to on specifically we are focusing on message bus here. So this is a static instance of a message queue manager. Then we are using a det to maintain all messages. We are maintaining a string. We are maintaining it in string format. And because we need to introduce a maintain the synchronization, so we have a mutex to manage it. And then there is a vector of all the proxies we'll use here, and then again one more mutex to maintain it. We will also use a condition variable so that we can write our messages more efficiently. Now let's see the implementation of proxy. So we are declaring all our headers, and this is the constructor for proxy. We are taking socket as a parameter and assigning it to the socket object. And the start function will trigger as soon as the proxy get created, and it will add itself to message queue manager. As I mentioned before, message queue manager is going to be our core class, and it's a singleton. So we are taking the instance of mq manager and adding the instance of proxy to mq manager. And as soon as the proxy starts, it starts reading. So we are using asynchronous communication in Boost. So I'm pretty sure if you have seen my previous video, you're already aware of what is asynchronous communication and benefits of it over synchronous communication. So you might have noticed that I'm not using threads here. So this asynchronous read function, we are using a lambda here, and as soon as it reads a message from a socket, it is going to add that message to mq manager using add message interface, and it goes back to reading. So this loop, it reads, add message to the queue, read, add message to the queue, and this is a cycle which it will follow. So you might have noticed that it is not blocking here. Blocking in the sense it is not that it's taking a message and broadcasting it to all other clients. It is not doing that. So this way it becomes more efficient. Now, as soon as there is an issue with socket, for example, if a socket gets disconnected, then mq manager will clear this proxy from its memory. Now there is another interface which mq manager will message queue manager will use to publish the messages to the client. So again we are using asynchronous write, and again using a lambda function here, and we are writing to this socket whatever the message mq manager provides here. It writes to the socket, client proxy socket, and then again it just, as soon as it writes, it goes back and it just wait wherever it is. So this, you see, it is very simple. So what we are doing here, again we are creating a constructor, starting the proxy, we are reading the messages, and there is an interface where which will be invoked by message queue manager whenever there is an update. As simple as that. That's it. Then let's see the message queue manager. Message queue manager is also it's similar to proxy. It's very simple. So we are declaring all our headers here, and then because it's a singleton and it's a static instance, so we are defining all these static variables here. You might have noticed all this static block, we are exposing it here. Now this is a thread safe implementation of a singleton. So every time somebody calls get instance, it will lock it, the mutex, and if the instance is not created, it will create an instance. If the instances already exist, it will return the instance and it will release the lock. So this way your code will become like more thread safe. Now, what is start? Start is a loop. So it will lock the message mutex So I mentioned that we are maintaining a deck to store all the messages. So it will lock it, and it's a condition wait. So it's very efficient here. So as soon as the message arrives, it will read the message and it will broadcast the message. Now, we already discussed about add message in our previous class. So proxy will use this interface add message to add a message to the message queue. So again, it is locking the mutex, and it is pushing back the message on the message queue. And as soon as the message arrives, it is notifying with the notify one. And then the message, the control will go back here, the condition wait will trigger, and this message will be broadcast. So you can see that it is forming some kind of like a loop here. But it's more efficient loop. It's not like a blocking loop. So again, the broadcast message is also very simple. So we already maintain a vector of clients, and every time the message needs to be broadcast, it will loop through the list of this client, and it will call the proxies update message interface. So it will send a message which it needs to be broadcasted, and it will get broadcast. Now, here is a interface to add a client. Again, it is simple. Simply add a client to the vector. And remove a client is exactly opposite of it. It will find it and it will erase it. So you see, it is not that complicated. It is simple. Now, this is the main function of our application. So here we are integrating all our code with starting point. So again, we are declaring header here, and our application is running on this hard-coded port 8080. Declaring namespaces, and this is server class. So server class, it's a constructor. It is taking the acceptor with the endpoints. Endpoints are the host and the port. And it will trigger accept, and it's again asynchronous accept. Again, this is a lambda, and it will create an instance of a proxy here. You see, we are making shared, creating an instance of a proxy, and we are moving that proxy to the message queue manager. So indirectly, it is going to trigger the proxy start. This one, and this proxy will get add itself to the message queue manager. So again, this is a loop. Every time a client requests for a registration, client's instance will get created, and it will be moved indirectly using the start method, proxy start method, to the MQ manager. And again, this will accept other clients. It's a loop here. So you might have observed how the beauty of this asynchronous communication, where we are not using threads and still we can serve multiple clients. So this way your code becomes much easier to maintain with this efficient asynchronous communication. So this is a main function of our application. So we are running at a port 8080. And we are creating a context of this boost asio context, and creating an instance of a server and providing context and port. And we are just using one thread here to maintain the message queue manager. So technically what happens here is this is one dedicated thread which will manage the clients and messages. That's it. And which is a worker thread in this case. And that's all. Rest of the code, it takes care of itself because of this asynchronous communication. Now let's see how can we execute it. So the client program for this demonstration is similar to what we have done before. in our other sample examples. So this is our client project, and this is the main. It's a very simple application which is requesting server the message bus. So we are declaring headers using namespace, and this is a function which is which is running on a thread and receiving responses from the message bus. So you can see here it is doing some it is reading the values from the socket and it is printing. So reading from socket, storing in a buffer, and printing them. And this is the main program, which is connecting to creating a socket endpoint and connecting to this endpoint, running our receiver on a thread, and on the main thread it is accepting data from which it is sending a data to the message server, which is getting broadcasted to all other clients. So this one is writing to a socket, reading a line and writing to a socket. And when finish, it is closing the sockets and cleaning up everything else. So it's a very simple client example, but if you have a graphical user interface like a trading blotter or any other order management client, you will have something similar where there will be some worker thread which will be connected to the message bus, receiving responses and updating your cache, and UI will display you whatever you have received on the main screen. So I think this is all in the client application. It is not a complicated, it is simple. Yeah, let's compile everything. Now, finally, we will see the execution of our program. So we'll start server first. Okay, it is running at port 8080. Then we will start one of our client. Now you can see that as soon as I started client, it got connected, and let me move a little bit here. Right. And I will launch another client, and the second client also got connected. If I am stopping a client, the first client got disconnected and the second client got disconnected. So very interactively our server message bus is maintaining the proxies here. So let's start again. First proxy, it got registered, and second proxy, that also got registered. Let me move the server. Yes. Yes. Now let's see. Now, if the first proxy is, or the first client is sending a trade message, this is not a very best example at this point of time, but this is more like a very basic things which will help you to understand the concepts. So suppose if a first trader is booking a trade and the trader wants to buy 100 shares of Apple. So it's saying Apple buy 100. As soon as it sends, this message is going via message bus to the other client. And if this user wants to sell 100 test class shares, TSLA, sell 100. Again, the other client got updated. Now, if this client wants to buy Microsoft share, MSFT, buy 50 shares of Microsoft. It got broadcasted here, and QCOM, sell 20. It got broadcasted here. So this is how you can actually make a very large and complicated distributed network of components. So here this implementation is very simple, where two clients are performing very similar things, but you can have a system where certain clients are registered to receive certain messages. For example, these two clients can be registered to receive only the trade messages, but you can have one more client which is registered to receive only security updates. Another one is to do something else. So like this, based on how the behavior is and how the implementation is, you can design a set of components here. So this is all for today, guys, and see you in the next video. And as I promised, we are moving towards building a more complicated system of our components. Something will design something like large trading systems or trading exchanges, and Twitter network or YouTube applications. So we're going to see all of them one by one, but one baby step at a time. Once again, thank you for your time, and once again I request you, if you have not subscribed, please subscribe us, and it will motivate us to get more interesting and more useful content for you guys. Thank you. Thanks for watching. Please subscribe to get more professional advice. In addition to our free online content, we also offer free online classes for students. These classes cover a range of topics, and they're designed to help you enhance your skill and knowledge. We encourage you to join us and take full advantage of this opportunity to learn and grow.